My name is Engineer Paul England. Welcome to our channel. In continuation from where we stopped when we did introduction to the first section in mathematics, you remember I said mathematics is divided into 5 sections and I break the 5 sections down. So this is the first section we want to talk about, which is number and numeration. So first we want to define and explain what a binary number is. A binary number is a number that is expressed in the base 2 numerical system. A binary number uses only 2 digits. The digits are 0 and 1. So anytime you hear of the word binary, remember 2. By 2. The digit it uses are 2 digits. Now, note this as you work as a mathematics student. Each digit in a binary number is called a byte. When you bring the digits in a binary number together, each of the digits is called a byte. Remember, a byte is a binary digit. Binary numbers are widely used in computers and digital electronical system because they are easy to represent with 2 states. So binary numbers are represented by 2 states, either off or on, or 0 and 1. That is how they are represented. Now, a binary number, for another definition, is also known as base 2. A binary number is also known as base 2. A base 2 number is a number that is made up of 2 digits only. The digits are 0 and 1. The binary system base 2 is the most widely used number system because apart from base 10, they are used in applications in our electronics, computers, and other devices. For instance, we use a phone, like the recording, for instance, now is using a phone, or let's say, for instance, your television set. If you check the on button, you'll discover that it is written as 0/1. That 0 means it is off. The 1 means the device is on. Therefore, the 0 denotes off, while the 1 denotes that the device is on. So base 2 basically uses only 2 digits. That is binary numbers. That takes us to a number base. Number base. A number base is also called a radix. A number base is also called a radix. What is a radix? A radix is a number base, and number bases are the foundation of numerical system. Number bases, they are the foundation of numerical system, and they determine how numbers are represented. Number bases determine how numbers are represented. A number base is also defined as the number of digits and the value or the place value that is used in the system. I take that again. A number base defines the number of digits and the place values used in the system. So we have some common bases. For instance, we have base 2. Base 2, also called binary. What are the digits in base 2? Remember we said base 2, it has 2 digits, 0 and 1. Base 2, 2 digits, 0 and 1. Base 3, how many digits? 3 digits. Base 3, it uses 3 digits, 0, 1 and 2. Base 3, 3 digits. Base 4, 4 digits, 0, 1, 2 and 3. Base 4, 4 digits, 0, 1, 2 and 3. Base 5 has 5 digits as well. Base 5 uses 5 digits, which are 0, 1, 2, 3 and 4. That takes us to, you have all the bases listed from base 2, 3, 4, 5, 6, 7 to base 8. Base 8, another name for base 8 is octal. Just as base 2 is also called binary, base 8 is also called octal. The digits that are used in base 8 are 0, 1, 2, 3, 4, 5, 6, 7. Why? Base 8, it has 8 digits. So we have 1, 2, 3, 4, 5, 6, 7, 8 digits. That is for base 8. You also have base 9. Then base 10. Base 10. Another name for base 10 is decimal. Decimal. Decimal uses 10 digits as well, from 0 to 9, which is 10 digits. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So base 10 uses 10 digits. Another name for base 10 we said is decimal. Then base 12 is also called duodecimal. Now, if you are doing mathematics a little bit above um, SS1, SS2, SS3 work, you will now have duodecimal, mostly used also in further mathematics and WAEC and other external examination. Now, duodecimal is base 12. The digits used are from 0 to 9. Then you have A and B. The digits used in duodecimal, which is also known as base 12, are 12 digits. What are the 12 digits? You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 11, 12. The A and B is attached to it. The A and B, remember, your A is equals to 10, your B is equals to 11 when you are dealing with duodecimal and hexadecimal. Hexadecimal is base 16. Another name for base 16 is hexadecimal. The digits that are used in base 16 are 0 to 9, then A to F. There are 16 digits, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. These are the digits that are used in duodecimal. Remember, anywhere you see A is equals to 10, B is equals to 11, C is equals to 12, D is equals to 13, E is equals to 14, and F is equals to 15. When you practice this and you are used to the number of digits that are used in each base, it will help us when we are solving our question. That leads us to a base number. What is a base number? A base number refers to the number of unique digits. A base number refers to the number of unique digits, including 0, that is used in a numerical system. The number of unique digits that is used in a numerical system. Example of a base number are, you have base 2. Now, a base 2 number, for instance, in base 2, the number is 2. The digits that are used in base 2 is 0 and 1. We have base 10, so I'll just pick only a few of them. Base 10. In base 10, the base is 10. The digits that are used in base 10 are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Base 10 is 10 digit numbers that it uses. All right, so then that leads us to the explanation on this part. The base number is usually written as a subscript. First, what do we mean when we say subscript? The base number is usually written as a subscript to clarify the numerical system. So anytime you write a base number, you must write it as a subscript. Remember, see, the subscript is attached below. You write it as a subscript. Why? So that it will clarify the numerical system. It will make this number to be different from the numbers that are written in a straight line. So you must write it as a subscript. Any base number you are using for solving. As you practice this, as we go to the next stage, you follow through carefully, you will be able to understand the concept of the entire thing we are doing. All right, example 1. We want to start with some expanding numbers in power of their bases. We already explained what a base is. So example 1. Example 1, expand 1, 1. Remember, we say you must write the base as a subscript. So expand 1, 1 in base 2. How do you do that? Solution. Remember, you are expanding 1, 1 base 2 in the power of each base. In the power of each base. The base is 2. So when you are expanding the power of the base, you write 1, 1. Remember, it's in base 2, 0, 1. How do you expand that? 1 times the base, which is 2, plus 1 times the base, 2. Write it on top, 0 and 1. You've expanded in the power of the base. I'll take another example. Example 2. expand 223 in base 4 in the power of its base in the power of its base. Solution. You write 2, 2, 3. The base is 4. On top this base, you write 0, 1, 2. So you now go by writing 2 times the base 4 plus the second number 2 times the base 4 plus the third number 3 times the base 4. On top the base number you write 0, 1, 2. Answer. You've expanded in the power of the base. So we'll take just one more example before we conclude on this. I call this example 3. Expand 11011 base 2 in the power of its base in the power of its base. How do you do that? Solution. So you have 1, 1, 0, 1, 1 base 2. You are expanding in the power of its base. How do you do that? 0, 1, 2, 3, 4. So you write this number. The first number there is 1 times the base is 2 plus 1 times the base is 2 plus 0 times the base is 2 plus 1 times the base is 2 plus the last number there, 1 times the base is 2. On top the base number, which is 2, you now write these figures. You have 0, 1, 2, 3, and 4. You have expanded 110, 11 base 2 in the power of its base. Thank you. Keep on learning.